Electric energy is one of Serbia's main products and exports. The biggest source is lignite coal, which accounts for roughly 65% of total electricity production. Lignite coal is mined using large-scale machines called bucket-wheel excavators, and 29 such machines exist in Serbian open-pit mines. These machines are very expensive and designed to last several decades, so preserving their functionality is vital for the well-being of the Serbian energy sector and Serbia's presence in the European energy market. In order to boost their performance, more and more bucket-wheel excavators are being equipped with frequency-controlled bucket-wheel drivetrains. While this is definitely an improvement, extra care needs to be taken when operating the machines with such modifications, as there is an increased risk of breakdowns and downtimes. Bucket-wheel excavators are controlled through the variation of three parameters: the inclination of the bucket wheel boom, the advance, and the slewing angular velocity. The machine operates under dynamic loading, which arises from the excavating subsystem, which consists of the bucket wheel and its drivetrain. Implementation of the frequency controller on the excavating subsystem introduces a fourth parameter, a variable number of bucket wheel revolutions per minute, which adds another degree of complexity to the system, which is already extremely complex. The relevant codes of standards are yet to account for this parameter, but they do provide the limiting accelerations of the key points of the bucket wheel excavators. These can be used as the cutoff criterion for determining the RPM spectrums, which can jeopardize the well-being of the machine. Using this as the foundation, the Rotodyna team will develop an algorithm for determining the unfavorable RPM spectrums for any combination of the four presented parameters. As it currently stands, the selection of the bucket wheel RPM is exclusively at the discretion of the respective machine's operator. Although a lower RPM number allows for the excavation of soils of higher resistances, unfavorable RPM spectrums often go unnoticed by the operators, which over time leads to intensive wear, failures, and breakdowns of vital subsystems. This can put the machine out of operation for prolonged periods of time with catastrophic financial consequences. The Rotodyna team proposes a systemic solution to this problem in form of a device we call AMPD controller. By implementing the presented algorithm into a PLC device, which would then be integrated into the control system of the target machine, the machine would be prevented from working within the undesired RPM spectrums, and its structural well-being would be preserved. Implementation of the device would not affect the predefined functional characteristics of the machine, nor require any additional training for the operator, leaving the machine intact and the operator's method of control unchanged. The Rotodyna team is ready to present the functional prototype of the device within 6 months of the project's approval.